next, now this is the time to encourage the spirit of next researcher. For that, I would like to invite for presentation. Uh, Topic is hematology disease detection using image processing. Okay. So, Janhavi, are you ready?
Yes, ma'am.
Okay. You can share your screen.
Yes, ma'am.
Good morning to one and all present here. Myself, NIDHI PATIL, and my three friends, JANHAVI, RUTUJA KADAM, and Mansi Kanade from BEIT, under the guidance of Amar Sir, would like to present before you our paper. Our topic is hematology disease detection and the domain is machine learning. Basically, hematology disease are disorders which primarily affect the blood and the blood forming organs. The motive behind choosing this topic was we get the results of the disease very soon as a project detects the disease with the help of images of the blood samples taken, and there is no need of the lab technicians and the skilled people to test the blood and give the results. And also while the blood donation, with the help of this project, we can help the spreading of the diseases from one person to another. Further, my friend Mansi will present.
So there are many studies in the field of machine learning techniques in disease detection, and few of them interested in blood diseases detection. In these two papers, the first one, which is risk detection of ischemic heart disease using artificial neural network, and the second one is deep learning models for retinal blood vessels segmentation. In this, they use machine learning algorithms based on blood test results. They built two models to predict blood diseases. First one is the predictive model. Second one, which to predict blood diseases, which is most of blood test parameters. And second one use only reduced set, which is most common in patient admittance. These two models achieved good result, as first one model gives 88% accuracy and second gives 59% accuracy. Though this research contains some limitations as well. Some parameters were not calculated like F measures, and recall that may lead to better results. Here we are using multi-class classification in the module. Nidhi, module slide. Yeah. We have implementation part like blood diseases and blood analysis parameters, machine learning algorithms, and third one is smart blood analytics. My friend Rutuja will explore more about it. So next in the module, we have four main classes related to four different blood diseases. Like thrombocytopenia, in which happens due to lack of platelets, which is not dangerous, but sometimes leads to bleed too much. Then next we have leukocytosis, which happens due to increase in white cells, which cause parasitic infection or bone tumors, as well as leukemia. Next one we have anemia. It happens due to decrease in amount of hemoglobin or RBCs, which cause tiredness, shortage of breath, or weakness. And the last one we have normal. It gives all parameters having normal range. Further, Rutuja will explain. Over to you, Rutuja.
Good afternoon everyone, and thank you Mansi. Now we will move forward. Here we will have a table of blood parameters. We have taken into consideration different parameters like age, white blood cells, sex, red blood cells, hemoglobin, etc. And the normal range values are given. So we will take one blood sample as an input and check its parameters if they are in the normal range or not. So in this way we will disease will be predicted. So next we have smart blood analytics. So smart blood analytics, it is a technique which uses advanced algorithm to provide a list of most probable diseases based on the input. It uses CNN algorithm is used. So we will have a web-based application that will easily take input and generate output. For example, if in the blood sample, if there is less amount of hemoglobin or red blood cells are less in amount, then it will give output as anemia as well as other possible diseases will be predicted. So it will show 10 most likely diseases through a polar chart. So that chart, in that chart, each segment will represent possible diseases, and the angle between each segment will give us the probability of that disease. So moving on to the applications. So as mentioned earlier, by using smart blood analytics, we will get list of 10 most probable diseases, and the second application is that human errors will be minimized and it will give us high accuracy, and we can reach diagnosis in very less time. So it is uh, we can quickly reach a diagnosis by using this method. Next, my friend Janvi will explain next slide.
First of all, good afternoon, one and all, and thank you, RUTUJA. So now I would like to conclude here. In this topic, we studied how ML is essential technique for modeling the human process, especially in medical field. So due to its high availability of data, and also as we know, blood analysis is the main factor for any disease detection because it contains many parameters that too with different values which indicates a definite proof for disease existence. Even the accuracy of machine learning algorithm, it mainly depends on quality of data set. And this data set is used for training the classifiers and for obtaining high accuracy. So now I would like to go for future work of the same. So here we will get to know that machine learning models can recognize diseases related to blood laboratories pattern which are beyond current medical knowledge. And as comparison to traditional quantitative interpretation, this gives higher diagnostic accuracy based on ranges for blood parameters as shared by our friend Rutuja. And also adopting this approach in blood laboratories based diagnosis could lead to fundamental changes in differential diagnosis and reduce the late detection of disease which may cause to death sometimes. And we can also expand the scope of this system to another type of diseases as well. Thank you.
Just one question. As this is your seminar, have you gone through any databases, or which database has been widely used by various researchers? Can you name the database?
Here we have used primary data sets, sir. So we have first collected.
Name of the dataset. Name of the dataset. Have you collected yourself? Then and then it will be called as a primary dataset.
Yes, sir. We have collected it ourselves.
From where? Which clinic?
Here, I have my family friends who are doctor, so I took their help, and with them help, I have collected this information.
For how many number of patients?
So actually, we have collected for 7 diseases, and we are still in process. And we are for one diseases we are taking 4 to 5 patients information.
Okay, so for 7 diseases, 5 samples each.
Sir, actually, for one particular disease, we have around 1,000 images, and like that we have for 7 diseases.
So have you collected that much, or you are using a ready-made data set? That is my question now.
We have collected.
Sir, we have collected and then we have used data augmentation on that.
Okay. Okay.
Thank you, all of you, for sharing your reflective knowledge with us. Okay.
Thank you, ma'am.
Thank you, ma'am.
Thank you.
Thank you, ma'am.